Recording. Alright, continuing on with the component level review of this motor drive that I'm building. So far the review has been very productive. It has revealed several mistakes that I've made when first putting together the schematic. I'm continuing to move through every single component and making sure that it has the right footprint and the right function on the schematic. Now I'm going to move to switches, then I'm going to go through the test points, probably going to add some test points, and then I'm going to go to the bulk of the review, which is reviewing the ICs that I have on the schematic. But let's start with S1. So S1 I think is the reset switch. We'll see. S1. Yep. Let's see. So S1 is a reset switch, and I'm going to show the data sheet of this switch. Let's see. This is a small button, and it has a footprint that looks like this. Let's see, like this. So this is the footprint that we need to make sure that this button has. Now, the current footprint, let's see here. Right, I'm just gonna check. Let's see, 1, 2, 3, 4. So 1, 2, 3, 4, and then there's a switch in between. And this is supposed to be an off, and then in parentheses on switch, which means that it's off by default and it's on momentarily when you press it. Does it say anything about that? No, it doesn't. But it probably will say here if I search on Mouser for it. Oh, of course. Let's get the article number here. For some reason, the suggestions are not coming up anymore. I have no idea why. Off, on, exactly. Tactile switch, and let's move on to this. Let's see. Let's close a bunch of windows here. Yep, and I have this switch. Where did I have this data sheet for this switch? Let's see. Oh, it was the PTS. Okay, there we go. This one. So now checking the footprint for the switch, I can copy this. Let's see. The footprint is wrong, obviously, because I copied the component in my library from this switch to this switch, and then I just forgot to set the footprint on that component, which is exactly why I'm doing the component level review. And actually, I'll just create a new footprint for this, and then I'll update the component itself in the library. So what shall we call this footprint? PTS 540. Let's see. And it's going to have pads that are 1.2 and 1.3. Let's see, there's 1.3 divided by 2. Where is it? Let's make sure. So we have 3.4, and then that will be 0.65 on the Y, and 2.7 minus 2.5, and 0.6 on the X. Let's see. S and V, and rectangular 0.6 and 0.65, like that. I kind of suspect that X is always sort of like in this direction, but with respect to the coordinate system of this pad, because yeah, it's definitely like that. So have to be careful to place the pads with text rotated in the right way, so that the pad is sort of aligned with the coordinate system of the grid. Let's see. So position of this pin is going to be, let's see, so it'll be 3.7 divided by 2 minus 0.3, so minus 155. And the Y position would be 3.4. Let's see, 3.4 divided by 2 minus 0.325, because it was 0.65, so 1.375. Let's see. Two and 1.55. No. That. And then I have this one copied. See? So I'm gonna place it exactly where it was. And then this is 3, yeah, so that's 3, 4. So 3 will be 4. So like that. Let's see, and this would be custom and switch. But I'm just gonna check that we have 3.7 and 3.4 like this. That's 3.4. This one is not 3.7. It's 3.8. So let's see. So 3.7 minus 2.5 divided by 2. No. That's 0.6. So that should be 3.7 divided by 2 minus 0.3. Yes, it has to be 155. Okay. So it could be just that because of the grid, we have. Let's see. Let's try to measure this. So we're starting off a little bit outside and we're kind of ending a little bit outside. So it's gonna be 3.7 pretty much if we start in the right place. Okay. The silk screen can be kind of like just something that goes around this. I'm not gonna spend too much time doing the silk screen. I just want to sort of move the ends of this line so that they are like that. Yeah. And finally, I have to assign this footprint to the switch. Yeah, and I have to add the courtyard as well. I'm gonna do that. It's good to get the courtyard as well done right away. So front courtyard will be, let's see, can do it like that. Just need to move this one a little bit. Alright, and the fab layer as well. The fab layer is used to create this simplified diagram of where the components are placed. it's kind of I rarely generate it, but since pretty much all components have a fab layer drawing, it's good to have a fab layer diagram on each component that I create in my library, so that it then is consistent when a fab diagram is created. Let's see. Okay. And then I can green light this one, and S2 is a dip switch. So S2 is the switch that I use for the idea is to use it to set the lower bits of the can open address. And this is useful if boards are if you have several boards on a machine and some board is replaced, it's good to be able to set the address of the board through hardware and not have to program the board ahead of time. Let's see. So this dip switch is a small switch that we can check the datasheet of. We're going to make sure that it has the right footprint as well. Let's see. Looks like this, and then there is a footprint here. So we have, let's see, let's open up this footprint that we have. This is a SOIC, it's a generated one. And I know this footprint works because I used it before, but I still want to double check it during this review, because since this is a generated footprint, it could have small discrepancies, and it's generally better to make sure that the footprint is exactly the same as the datasheet says that it should be. So we have 4.9 between the pins, which I'm pretty sure this is not 4.9, but we can see. Yeah, that was pretty much exactly 4.9. That's good. So 7.4 on the outside. 7.4. That's good. 0.76 like this. 0.80. That's good. So because of the grid, the cursor stops slightly outside of the pad, and then there is yeah. So everything is pretty much correct here. No problem at all. 1, 2, 3, 4, and then 5, 6, 7, 8. Yep. So this one is can green light that one. And then all of the test points. I'm going to go over the test points that I have in the schematic right now, and then I'll see if I can find any other places where I have to place the test points. Let's see. Actually, with regards to like free pins on the microcontroller, I'm going to place test points on them, because then I can use those pins to output like a direct GPIO signal in order to debug things like timings, interrupt latencies, and things like that. So I think it's I usually use the diode, like the LED that has that is connected to the STM32 to do that kind of thing. But it's also nice to have more than one pin to be able to see the timings between different things. Moving on to test points. TP1. So we've got test points on the inputs to multiplexer, which is here. And let's see. Yeah, we're gonna have to review this chip and see what the inhibition input does. But with regards to test points, because so I cannot see the test point reference here. I'm gonna do like this. It's obviously a good idea to see the test point reference. So this one, or actually I'm going to do like this because sometimes it doesn't work to set the visibility. I'm going to set this visibility to visible, and I'm going to update the field values. And unfortunately, because of the way KiCad works, if you set any visibility settings in your schematic, then the KiCad will not update the visibility settings when you update the fields, which is undesirable. I have to change that and make sure that all the visibility settings are updated. So what we can do is I'm going to close this schematic. I'm going to save and exit, and then I'm going to go to the terminal and I'm going to edit the schematic manually. So let's see, where is the test point? TP1. So there is H. I think that stands for hidden, but I want to just see what I have to put there based on, let's see. It's hidden. Well, actually, maybe H does not mean hidden because, for example, P27 is not supposed to be hidden. Yeah, it seems to be that it's the L and the C. So let's see. Let's see if this works. So we got TP12 and let's see. If we make this L, does this make our test point field visible? No. Okay, so what I can do is I'll close this one and I'll go to the TP12 and I'll set the reference to show and I'll save the schematic. what does it say now? So maybe that was not. Maybe it's sort of. Maybe it's this little flag here. Let's see if this does the job. So we got TP12, and let's find TP13. And the cursor is nowhere to be seen. Where's the cursor? There. All right. So it seems to be that little change that had to be done to that flag, which comes after a bunch of numbers. So we have to set. Let's see. So we have to change that to 0. Right. Let's see what would be the best way to do this. It's always field 0 and it's always starting at TP. So maybe we can substitute, let's see, well, we have to ignore these numbers. I'm going to start with just searching for the TP fields and setting this to 0. I think this would be the safest way to do this, because I don't want to spend time to try to come up with a regex that will match only the TP fields and replace everything correctly. So I'll just go like this, and then let's see. Yeah, this is manageable. This is definitely faster than trying to create a regex that will not mess something up. Let's see, and I think we should be able to close this without having to save anything, right? Let's see, P41. It's so nice that KiCad has an open format, so if something is not working in the program itself, just open the file with the text editor and fix it. This is a major benefit. Like, even if KiCad has many problems and like many things to wish for, just the fact that it has an open format is fantastic. I cannot, for example, with Altium, like, or with any software that sort of forces you into this, which enforces a policy on how you should work. Like, they design it in one way, and that's how you should be doing things, right? And because you cannot access the format, you cannot write a Python script that will extract, for example, all of the component names with the manufacturer number and with with any information that you need. Of course, there are wizards where you can sort of see where you can make reports of things, and yeah, it's usually possible in some way, but if something is not really working, like for example, I had a problem with Altium where when I went to look for, let's see, no, when I had to copy a component from their online library to my own library, and there was some property of the component that when I tried to copy a component with like specific properties set, I couldn't do it, and the Altium would crash. And then it's like, okay, so I have no way of solving that in that version of Altium. That was very annoying. I wish there was sort of I wish there was like means to solve an issue using other ways. Like so, the Unix philosophy is that you provide means and not policy. So you provide ways to do things, but you do not impose a policy. And when you have open format, you provide means for somebody who is willing to understand the format to make any changes to the file without having to conform with some policy of your graphical interface. And that's very good, I think. That's a very desirable concept. So in my electronics, on my boards and my schematics, I always try to think to provide means but not policy. So I provide means to interact with other devices by putting a UX connector, right? I provide means. I do not impose a policy that says that you have to go through some specific interface. You know, I try to provide as many means as possible, because that really helps during development and saves time. I think I've changed all of the test points now, so I'm going to go to let's see. I'm going to move this window here so I can have all of them open at the same time, and I can open the schematic here. And hopefully now we can go over the test points. Let's see, so we have TP1, 3, 5, 7, and there is TP2 here. So 1, 2, 3, 4, 5, 6, 7, 8. So all of these test points, 1, 2, 3, 4, 5, 6, 7, 8. They're green. Then we have TP10. TP10, 11 is also green. So these two test points are in order to be able to measure the current consumption of this whole of all of the logic, basically. So this is a current sense resistor, and if you just put a multimeter here, you can measure the voltage across this resistor, and then you can just calculate the current based on the resistance of this resistor. Let's see, and this is TP17, and TP16 is also one such resistor. So TP17 and 16, 12, 13. I'm thinking whether this is really necessary here, because it seems to me that R65 is just completely unnecessary, because we're not going to be feeding anything. We're not going to be feeding anything here outside of this regulator, so we can just remove this. This is not necessary. Let's see. Yeah, so I'll remove this because to measure the current for the MCU and anything that's connected to 3v3 supply, the main 3v3 supply, I would use the test points here. So let's see. I didn't look at the test points that I just removed, but we'll have to just greenlight anything that doesn't appear in the list there. So 1920. And TP12. TP12 is used to see the voltage that goes from this digital potentiometer into the op-amp. So 12 and 13. That's useful. And then we also have 14 and what is this? Okay. 14 and like that. 15. It's like, even though KiCad provides a way to sort of change the visibility of the fields from the UI, it's a lot faster to open the file in the text editor and just search for all the test points and make sure that that everything is visible. Because, for example, now when I find TP12, I can also see that TP13, 14, and 15 are okay, and I can just greenlight them at the same time. So that saves time for me. 12, 13, 14, and 15. TP18. TP18 is for the power good output of this regulator. Let's see. Yeah, and also so TP17 also serves double purpose. One purpose is to see the voltage, and that comes out of this regulator. And the same thing with TP10 and TP19, which is good. But we also need to place a test point, just one test point here. And this would be for the 3v3 supply. And I'm gonna wait to annotate this. I will see which test points I didn't. So I removed 2 test points here, but I didn't look what number they had. So I'll assign manually a number to this test point. Now I'm gonna go to TP18, and that was okay. Yeah, that's for the power good, so we can greenlight that one. And then TP21. It could have been TP21, I think. I'm pretty sure it's TP21. Yeah. So we can make this one TP21. And then TP22 is probably also not going to be found. So we can, greenlight that one. So it was 21 and 22 that I removed. TP23. Alright, so these test points are for the signals that go, for the gate drive signals. So they are, let's see, so they're connected, they go between the MCU and the gate driver. Yeah, this is really messy. It's like maybe all the test points should have like just a T letter. Not TP, but T. I think that would be better, actually. I don't think there is anything else that uses the T. There is actually a, let's see, this is interesting. component reference designator format standard. Let's see. I think there is a standard way of doing this. Yeah. Let's see. Where is the test point? Yeah, it's TP. Okay. So let's keep it as TP. It's just a little bit longer than would be optimal, because test points are usually appearing close to each other. So even on the board, on the actual silk screen, it's going to be space consuming to have all of these designators there. Anyway, 23, 25, 29, 31. Let's see. 23, 25, 29, 31, 33 and 35. And 24, let's see, TP27 is 27 and 39 are the current sensing outputs. So 27 and 39. They're also okay. Just need to move this one like this. So another quite obvious benefit of doing component level review is that you can also clean up the schematic and make sure that all of the text fields are visible properly. So TP, let's see, let's move to this one then. So we got TP28 and TP40. And then all of these. Twenty-four, 26, and 30, 32, 36, and 34. Great. And now we have TP37. Let's see, TP37. That's for our current adjustment. And did I have a TP on here? Yeah. So we got TP37 and 38. These are our current adjustment. And TP41 is for the, right, that's for the brake resistor. And is there anything else here? I think we should place a test point here as well. And then, let's see. Is there anything else? Let's see, TP41, and let's just finish this. So TP9, and also I think I'm gonna have to place some test points here as well. Just right away I can see that I needed to have a test point here, because this would be the VMOT sensing, and not only that, but also I have to have a test point here. Let's see. And then we have these ones are just unused sections, and just the last one, TP9. Right. So TP9 is just the input to the microcontroller, or the output of this multiplexer. Okay, so we got all the test points that I've had on the schematic prior to the review, but I think I have to make sure that let's see. I have to make sure that we have test points at all the places where it's necessary. I'm going to place some test points here as well. So let's see. Because we are not quite sure about this EEPROM, I'm going to place test points on the SCL and SDA because God damn it. So I'm going to place the test points on SCL and SDA in order to be able to see if there is any traffic there without having to poke on the pins of any chip. And especially when using like QFN packages, it becomes a little bit problematic to poke on pins of any chip. So having test points is very useful. Let's see. We need a test point here. This would be, or actually no, we don't need a test point there because we have this connected to the connector. So our connector is the test point. Let's see, do we need CAN? No, we may need CAN TX. Although in this case, I'll just, let's see, we don't have any, or we do, yeah, we do actually have a standby. I think I'll skip test points on that because this chip is a SOIC, I'll just check on the pins if absolutely necessary. But I can always check on the CAN-H and CAN-L on the connector. So that is solved, and we have, let's see. We got the switches here, but I think that yeah, kind of knowing that we have signals on the outputs here, I think that would be useful because we cannot, because we have sort of this chip is going to be doing debouncing. So it would be helpful to see the delay that the signal has here because we cannot read it out fast enough to be able to see the delay. So let's put some test points here. Yeah, and on the RQ as well. No, no, please, no. No, I don't want that. I want to duplicate the block, and I want to just place the test points. Let's see. Copy that, and just moving on through this list here. So this is definitely going to be useful. And I think placing some test points on interrupts is actually very useful in any case. So let's duplicate this and place some test points there as well. Right, and then we have this as well. Duplicate block. Okay, so apparently I cannot move the references like that. I have to... No, I can't even move them anywhere. It's interesting. Why can I not move the references? Yeah, there we go. Okay. So, what else here? Let's see. So hopefully the test points of 1 × 1 millimeters are going to be fine for most of these components and can just be placed as sort of like along the track. It can be a little bit problematic to place test points for high-speed signals, because if you have like a differential line and you have to place test points, then you have you either have stubs or you kind of have to separate the differential line. But on this schematic we don't have any signals that are of such high speed that would be an issue, I think. Let's see. Is there anything else here? There is actually probably... I think we should actually place test points here. We should definitely place test points on the offset here. So that we can see what the offset is. Let's see. And the offset here. And then there should be a test point on the input of this amplifier, as well as probably the output. So the input here would be the voltage sensing signal, and the output would be an amplified voltage sensing signal. So we should at least have, we want to make sure that this signal has a proper offset, and then we also want to make sure that our output signal is correct as well. So I can place a test point there. So I'm pressing C in KiCad to copy a component. Okay, we have all the test points. It looks like they're, yeah, cool. So let's see if there's anything else. In terms of the raw signal that goes here, we have some resistors here. It's always easy to test on the sides of the resistors, so I'm not going to be placing any test points there. possibly test points for the HAL, but because that is a connector, we can easily just test on the connector, and it's one of these. It also has screw terminals, so the testing on the screw terminals is easy enough. Let's see. The DC cal, maybe. Although this goes directly to a GPIO pin, and usually that works without any problems. And this chip has, let's see, yeah, this chip has exposed pins, so it's always possible to test directly on the pins. It's much more important to have test points here, for example, because it's dangerous to test directly on the pin. You could easily short 2 pins, and that would just mess up the commutation of the motor. But in this case, there is like ground and overcurrent adjustment. Yeah. DC cal. Do we need a test point there? Let's actually place test point on both the gain and the DC cal. That would be useful, I think. And then the same thing here. So we have gain 2 and DC cal 2. And we can place a test point there. Okay, temperature sensing, of course that should have a test point. Knowing the voltage that goes into the temp sense ADC input is very useful. Let's see. And the same thing here. Okay, what else needs a test point? Overcurrent adjustment has test points. Let's see. So EtherCAT, let's see. Possibly all of these signals, because it would be nice to have them close to the EtherCAT chip and to be able to test them without having to poke around on the STM32. Let's see. Test point. May as well have test points on all of the control lines, because this EtherCAT chip is under evaluation, so I'm evaluating this component. Oh crap, no, what did I just do? Oh Crap. Okay. I'm gonna do like this. Let's see. Duplicate block. And I'm gonna do it properly the second time. Let's see. Yeah. So knowing what goes in and out of this chip is important, is of special importance in this case, because I don't know how this chip behaves. Let's see. Okay. Is there anything else here? We have maybe test points on here. Let's see. And I want to have test point on the int and on the CS pin, just so we know that it's selected, and so we can see what interrupt it produces. Let's see. There we go. Anything else here? I think this is fine, and I'll just place test points on the unused pins here. And when I have test points on the unused pins, I can also solder wires to them if absolutely necessary. So that's very useful feature to have on the PCB. Okay, so done with all the test points. So I'm gonna stop this video now and leave all the ICs for the next video. And it looks like I'm almost done soon with all of the components. There's just the ICs left. But the ICs, they are themselves, they're gonna take some time to review, because I have to review all the pins and make sure that each pin is connected to the right signal, and make sure that each signal can be read on that particular pin. So it's gonna take some time, but I take it one small bit at a time.